So in the last couple of videos, we've actually learned how to get the expected value, how to get the variance, how to get the standard deviation, and how to use the concept of the complement rule and the cumulative probabilities. So in today's video, I'll be trying to solve some questions that will make us have like a revision kind of thing on the topics we've actually treated in the past few videos. So I have like a question, and this single question has like 3 or 4 sub questions that actually touched all the things we've actually talked about in the past the 1, 2, 3 videos. So I'm actually going to display the question right now so you can just take a look at it and see if you have an idea of what we're talking about. So you can pause and take a look and try to solve and give me your answers and let me know in the comment section what you got. So without further ado, let's actually jump into the video and start solving this question properly. So the question says that a biased die with 6 faces is rolled. The discrete random variable x represents the score on the uppermost face. The probability distribution of x is shown in the table below. We can see that we have x, that is 1, 2, 3, 4, 5 down to 6, and we have the probability attached to each of the random variables, that is p into bracket x equals to x. We have a, we have a, we have a, we have b, b, and then we have 0.3. Now the question is now telling us that given that the expected value is equals to 4.2, we're supposed to get the value of a and b. And the second question says that find the probability that x is actually greater than or equals to 3. And the third question is we should calculate the variance and the standard deviation of the data set. So for us to be able to actually solve this question in the right manner, we need to get the value of a and b. Now we need to also recall that in the past videos, we've talked about the fact that for a discrete probability distribution, the sum of all the probability values must actually be equals to 1. So that means that a plus a plus a plus b plus b plus 0.3 must actually sum up to give us 1. And it was also stated in this question that the expected value is actually equals to 4.2. So that means if you try to use our data set to calculate the expected value of this data set, whatever thing we have, the answer should be actually equals to 4.2. So I would actually have to go into the worksheet and try to reconstruct the table in a way that it's going to allow us to be able to get the value of the expected value. So the formula for the expected value is actually equals to E of x is equals to x times P of x summation. That is, it is the sum of the product of each of the random variable with its corresponding probabilistic value. So let's create a space for x times P of x, that is each of the random variable multiplied by its corresponding probabilistic value. So 1 times a, we have that to be equals to a. 2 times a, we have that to be equals to 2a. 3 times a gives us 3a. 4 times b gives us 4b. 5 times b gives us 5b. And 6 times 0.3, that actually gives us 1.8. So the sum of all of those products should actually give us the expected value. That is, a plus 2a plus 3a plus 4b plus 5b plus 1.8 should give us the expected value. Now we're told that the expected value is actually equals to 4.2. So that simply implies that a plus 2a plus 3a plus 4b plus 5b plus 1.8 must be equals to 4.2. Let's try to do a bit of algebra here. We have a plus 2a plus 3a, that gives us 6a, plus 4b plus 5b, that gives us 9b, plus 1.8 is actually equals to 4.2. So let's take the number down to the right side. We have 6a plus 9b is equals to 4.2 minus 1.8, and that gives us 6a plus 9b is equals to 2.4. We can tag this as equation 1. That is 6a plus 9b is equals to 2.4, and that is our equation 1. So we need a second equation rather for us to have 2 sets of linear equations to be able to get the value of a and the value of b. So for us to get the second equation, we need to realize that the sum of all the probabilistic value in a discrete probability distribution must be equals to 1. So that simply implies that a plus a plus a plus b plus b plus 0.3 must be equals to 1. And when we try to do a bit of algebra, we have a plus a plus a, that gives us 3a, b plus b, that gives us 2b, and when we do the math, we have 3a plus 2b plus 0.3, which is equals to 1. So let's do a bit of rearrangement. We have 3a plus 2b is equals to 1 minus 0.3, and that is 3a plus 2b is equals to 0.7, and this is the second equation that we are looking for. So our first equation is that 6a plus 9b is equals to 2.4, and our second equation is 3a plus 2b is actually equals to 0.7. I won't go through the process of trying to solve this using the elimination method or the graphical method or substitution method or something like that. I will just use a calculator. You can use any online calculator you can find, or you can use the normal calculator you have on your phone. So I'll be using an online calculator, and I'll be getting the value of a and the value of b directly. So from my calculator, the value of a is actually equals to 0.1 and the value of b is actually equals to 0.2. So that simply implies that if we withdraw the table, we are going to be having 1, 2, 3, 4, 5, 6, and all the a's will be replaced with 0.1 and all the b's will be replaced with 0.2. So we've answered the question that says find the value of a and b. So the value of a is equals to 0.1 and the value of b is actually equals to 0.2. So the next question right here is telling us to get the value of probability that x is actually greater than or equals to 3. And from the last couple of videos we talked about, the probability that x is greater than or equals to 3 is equals to probability that x is equals to 3 plus probability that x is equals to 4 plus probability that x is equals to 5 plus probability that x is equals to 6. And that is going to be something like 0.1 plus 0.2 plus 0.2 plus 0.3, and when we do the math we have our answer to be equals to 0.8. We can also decide to use the complement rule to actually solve this question by saying probability that x is greater than or equals to 3 is actually equals to 1 minus probability that x is lesser than or equals to 2. That is, when we sum, for us to sum from 3 to 6, we have to say 1 minus summation from 1 down to 2 or 2 down to 1 rather. So probability that x is lesser than or equals to 2 is equals to 0.1 plus 0.1. So that's probability that x equals to 1 plus probability that x equals to 2. So we have probability that x is greater than or equals to 3 is equals to 1 minus probability that x is lesser than or equals to 2. And that's 1 minus 0.1 plus 0.1. And that's going to be 1 minus 0.2, which actually gives us 0.8. As you can see, we still have the same answer. You are going to appreciate the beauty of complement rule when we start talking about the other types of probabilistic distribution. I'm talking about things like the Bernoulli, the normal, and stuff like that. So for our next question, we're supposed to get the variance and the standard deviation of the same data set. So we need to know that the formula for our variance is actually equals to summation x minus mu all squared times p of x, where the mu right here represents the expected value. Remember I said that the expected value is the same as the population mean of the distribution. So the variance formula is actually equals to summation x minus mu all squared times p of x. So the first thing we have to do is to try to rearrange the table and get something tangible out of it. So we first of all to get the value of x minus mu, and that is each of the random variable minus the value of the expected value. So the value of our expected value, aka the population mean, is actually equals to 4.2. And when we do the math, so we have 1 minus 4.2, we have minus 3.2. 2 minus 4.2, we have minus 2.2. 3 minus 4.2, we have minus 1.2. 4 minus 4.2, we have minus 0.2. 5 minus 4.2, we have 0.8, and 6 minus 4.2, we have 1.8. Now the next step is for us to get the squared of the deviations, that is x minus b all squared. So we have a minus 3.2 all squared, that gives us 10.24. Minus 2.2 all squared, that gives us 4.82. And we do that down to 1.8 all squared, which gives us 3.24. So after having that, it's time for us to multiply the square of deviations with the corresponding probabilistic value. So that means 10.24 times 0.1, we have 1.024. 4.82 times 0.1, we have 0.482. 1.44 times 0.1, we have 0.144, down to 3.24 times 0.3, and that gives us 0.972. So we have this, and then the sum of all of this is actually going to give us the value of the variance. So that means 1.024 plus 0.482 plus 0.144 down to 0.972 is going to give us the value of the variance, and when we sum this, we have our answer to be equals to 2.758. So the value of the variance is actually equals to 2.758. So the standard deviation is actually equals to the square root of the variance. So our variance once again is at 2.758, and when we take the square root of 2.758, we have our answer to 3 decimal places as 1.661. So the value of the standard deviation is actually equals to 1.661. So, and this is how you solve questions that comes in a very tricky way when it comes to the concept of discrete probability distribution. In our next set of videos, I'll be talking about the specific types of discrete probability distribution. I'm talking about things like I'm going to be starting with Bernoulli, then move to binomial, then Poisson, and stuff like that. So if you learned something new from this video and you actually really enjoy this video, I would really appreciate if you can give this video a thumbs up, like a like, and then also subscribe to this YouTube channel. It really means a lot to me. Do you have some questions for me, or you feel like I missed something along the line? Please go to the comment section and drop them. Trust me, I am really waiting and will be so happy to attend to them. So thanks for making it to the end of this video, and we definitely see you in the next one. Bye for now.